Okay, good morning. I'm adjunct professor Juha Heiskanen from the research unit of sustainable chemistry. And my topic is HMF and furfural-based synthetic biopolymers. In the production of synthetic biopolymers, we can utilize any type of biomass. It can be wood or something else. But the main components which are produced from the biomass, which are important for us, are HMF and furfural. At this point, it's also important to notice that how those currently known fossil-based plastics are produced. One of the most well-known plastic is PET plastic. It's used in water and soda bottles, which are produced annually about 500 billion units. So the main component of PET plastic is terephthalic acid. It takes 3 steps from terephthalic acid to manufacture PET plastic. It's mainly produced from fossil-based sources, crude oil, and now it's interesting to try to find bio-based materials to replace, for example, PET plastic. One of the most promising alternative is HMF derived PEF polymer, which is already known a couple of decades, and it's going on the commercialization in Europe and in United States. Also, I forgot to mention that there's ongoing studies in the universities and industry that to make terephthalic acid from biomass sources, but it's a very challenging task, and for example, some of those roads go from the furfural to terephthalic acid, and from furfural to terephthalic acid it takes 9 steps. So it's very time-taking and an expensive process. Currently, there are only very limited number known materials which are based on the furfural. In the University of Oulu, we have chosen this strategy to find novel ways to utilize this important chemical. And we managed in that. This polymer was published on last year, and it gave interesting properties, which I will tell you about shortly on the next slide. But at this stage, it's also important to notice that we are covered by the plastic all over the world, and those soda cans, they are not the only application where we can use those. There are also very high-end applications in plastics. For example, PET is one of the most used substrate materials for printed electronics, so very high-end application. And it's interesting that also various biomass sources have been utilized in these applications. For example, nanocellulose has been used in the substrate materials for printed electronics. As well, there's quite recent publication from utilization of PEF in the substrate of organic solar cells. So this is a good demonstration that those new type of materials can be utilized similarly in very high-end applications as well. About our PEF, it's one of the most important properties that if we compare the optical properties of PEF and PET, they are very similar. but there are the one very important difference, because when we prepare the film samples from both of these plastics, we realize that actually from the UVA radiation, about 80% goes through this PET film layer. But what is important is that these PET film materials, they are completely UV blocking materials. And this is not a common feature in the plastics. If you have a UV blocking plastic, there's usually some special additive added in that plastic to make it UV blocking material. Some other benefits and properties of PEF and its derivatives, which we have observed, is that they behave exactly like fossil-based plastics. They are more related to fossil-based plastics than for example, if we compare to cellulose. Those materials can be produced so that the carbon in those materials are 100% derived from the biomass. And we have shown that also the furfural can be utilized in the production of these novel type of materials very efficiently. As already mentioned, those materials show very good optical properties, but also thermal and mechanical properties with the excellent UV blocking capability. It's also important to notice that these HMF and furfural-based synthetic biopolymers show very high oxygen and water barrier property, meaning that these materials can be very efficient, for example, different kind of packaging application where high oxygen barrier property is needed. There's a very recent picture from our sample. So this picture actually demonstrates quite nicely that already in the laboratory scale we can produce these materials efficiently in pure stage and process them so that we are able to make good quality films. Some future challenges which we have to face in this research is, of course, that we have to make different kind of properties and tailor the properties of these novel polymers, and of course characterize them in detail. This monomer synthesis of this bisfuran unit, it's needs some more optimization if we consider the possible industrial production. And of course, it's very important in future to be able to show some real-world applications for these materials. And it seems that, especially in Europe, automotive industry is highly interested about these kind of new materials. They are not interested about those so-called drop-in bioplastics like bio-PET, polypropylene, or polyethylene, because it's we can argue that is these materials even bio-based. Also, it seems that domestic appliance industry is very interested about these materials, and we hope that we can face this. We can see those materials in some real world applications in near future. Okay, that's my short talk, and perhaps some questions.